everyone, this is Miss Mate. We will be talking about similar triangles today. Obviously, you know what triangles are, but you don't, and you know what similar shapes in general are. So, for example, let's take a look together at these three Christmas trees. Do they look similar to you? I bet your answer would be yes, they look similar. What is the same, what is similar about these three Christmas trees? Guess how I got it? I took one of them and then I enlarged it or I made it smaller, but maintaining, and this is very important, maintaining the same proportions. Maintaining the same proportions. I did the same thing for these two candy canes. Make it smaller or bigger, but maintaining the same proportions. And the Santa, look at the Santa, is the same one, is just bigger or smaller. Okay, so now let's go back to our triangles. Why, when do I say that two triangles are similar triangles? These two triangles are similar, and I call them similar, and I write something like that. Triangle ABC is similar to triangle DEF if something extremely important happens. Going back to maintaining the same ratio, I am going to pick my creative pen and let's pick angle A. This angle A, do you see, must be the same with angle D. Then angle B will be the same as angle, guess which one? Angle E, you guessed right. And of course, the last one is angle C, that will be the same as angle F. So, how do I write that? Angle A is absolutely the same as angle D. Angle B is the same as angle E. And the last one, angle C, is the same as angle F. Okay, beautiful. Please notice the following thing. When I write that two triangles are similar, I maintain the same order of the angle. Angle A is the first one in the first triangle. Angle D is the first one in the second one. Then angle B is the second one in the first triangle. And angle E, B and E are the same, is the second one in the second triangle. And then angle C, I know angle C is equal to angle F. I maintain the same order. Good. Let's look together at a geometry sketchpad diagram and let's see what happens here. I have two triangles, triangle ABC and triangle DEF. And what I did beforehand, I measured the sides. I have side AB, side BC, CA. I measured all the sides and I did the same thing for triangle DEF. Now we're gonna calculate together something very interesting. We're gonna calculate together the ratio of AB divided, its ratio, divided by, let's move this a little bit, by the corresponding side in triangle DEF divided by DE. Let's see what we get. Enter. We got 254. Excellent. Now this is AB, side AB divided by the corresponding side DE. Guess what we're gonna do next? We're gonna calculate side BC, this is my side BC, divided by the corresponding side from the second triangle, EF. Okay, let's see what happened. Oops, what a surprise. It's still the same, 254. What else do I have to calculate? I have to calculate one more CA divided by the corresponding FD from the second triangle. Okay, I did that, and shouldn't be a surprise to you that the ratio of corresponding sides are the same. Now maybe this is a particular case. Maybe if I change the triangle, that won't happen again. Let's do that and let's see what happens. Please notice that whatever I do with my triangles, the ratio will stay the same. The ratio stays absolutely the same, doesn't change, which is quite surprising. Right? The two triangles are similar, so the ratio of the corresponding sides will stay the same. Okay, so let's go back to our notebook and let's write that. Two triangles are similar if their corresponding angles are the same, and more than that, something even more interesting happens. The ratio of corresponding sides will be the same. Let's write that. So I'm going to write AB, side AB divided by DE will be equal to AC over DF corresponding from the second triangle equals BC over EF. Okay, so what happens in two similar triangles? Corresponding angles are the same. Corresponding angles are the same. That's one thing. Corresponding angles are the same, and that's number one, extremely important for me. And one more thing happens. Corresponding side, the ratio of corresponding sides is the same. Okay, so we'll stop and we will continue with some applications a little bit later.